பார்த்திரோம்.
Okay. Please stay safe.
1 kilometer ಹತ್ರ.
Please be safe. Okay, don't go near the sea area.
ಅದಕ್ಕೆ ಹೇಳಿ ಕಿಲೋಮೀಟರ್ ಅಂತ.
Okay. Come on. So I think we have not completed the previous one.
ಸರ್
Right?
ನಿಮ್ಮ ಮನೆಯಲ್ಲಿ
ನನ್ನ ಮನೆ ಬಳ್ಳಾರಿ. ಇಲ್ಲಿ ಸೈಕ್ಲೋನ್ ಬರಬೇಕು ಅಂತಂದ್ರೆ ತುಂಬಾ ಕಷ್ಟ. ಮಳೆ ಬರೋದೇ ಹೆಚ್ಚಿಂದಿಲ್ಲಿ. Okay, so previous problem we have exactly stopped here. We have calculated the wear load, but we found that the wear load was very much lesser when compared to the dynamic load. So we are supposed to increase the wear load to meet our requirement. So for that we have taken this. Okay, so wear load is given by this particular equation. We need to calculate the value of K and thereby judging the values of BHN1 and BHN2 from the table. Okay, for alpha is equals to 20 and steel combo. For that, first you need to calculate the value of K in order to judge your BHN and BHN2. So this is why we are doing this. Why? Because your wear load value came below the dynamic load value. Okay, always dynamic load value should be smaller, I told you. But your wear load value came below the dynamic load value. That is the reason you are increasing the surface hardness. That is the BHN, Brinell hardness number values. How we are doing it? For that, you need the value of K. Thereby, you are extracting K from this sort of equations. Okay. Now, give me the value of K. I want everyone to solve this problem. I told you I will be keep checking because design is such a subject. It seems easy. It is easy. I'm not telling it as difficult, but the thing is, you have to solve problems in the class itself because this is the platform for us to discuss what need to be taken, why should it to be taken, why not that value to be taken. So if you discuss such stuff within the class, then you'll be perfect in design. Okay, so that is the reason I expect everyone to solve in the class. So if you solve in the class, more than if you sufficient. You need not revise also. You will do directly in the examination. I'm damn sure about it. 1.14. So go to the table and check the values of BHN just above 1.14. Okay, just go to the table and check what was the table number. K value iruttala. Yes, I think this, right? For 20 degree stub teeth and steel combination, go for 1.14 above. Okay. So steel combination 1.14 above. 1.14, 1.15 I have, right? 1.14, okay. So 1.108 there. Then you can go for 1.34. So this is the thing, isn't it? This combination you can go. Okay. Since it is 350 here and 250 here, since both the materials are of same material, I guess, right? BHN, I mean, the gear as well as the pinion is made up of same material. What you can do is, you can give this particular value of here, like C. So it's 1.34. So for 1.34, you have 350 and 250, isn't it? Two different materials. It resembles that. It says that 350 is a different material and 250 is a different material. So you should not do that. Why? Because in the question only it has said it as both are made up of same materials, and all the calculations we have done thinking that gear and pinion both are having the same material. So what you do is just take an average of these two. 350 plus 250 divided by 2. I think it comes around 300, right? Am I right?
Yes, sir.
So that particular value, you can just write it here. Therefore, we have how much? 300. Okay. If you just see the question carefully, at the last he has asked to calculate the axial thrust force. So this axial thrust force would only come in helical gears. It will not come in this thing. Which one? The spur gear. It would only come in the helical gear. For that, you have a formula which is given by equation 12.21 in the page 211, which says Fa is equal to, which is the axial thrust force, is equals to Ft, which is tangential force, into tan beta. Beta is your helix angle. Just substitute and calculate your axial thrust force. Which is the value. One two nine seven. So 1 2 it's 1297.41. Is it correct? So there you end this particular problem. Now immediately we'll move on to the next problem. Here. This is again a same problem, nothing different. The only, see, for every problem, if you observe, there would be a little bit additional concept would be there. If you judge that your whole problem, that means 90% of the problem would be same. Only 10%, only 5% of the additional concepts would be there. That you have to search for every problem. Okay. See, as in this case, he says, design a pair of an equal diameter, 20 degree stuck teeth helical gear. So this is helical, this is just right here. So he says equal diameters in the sense there is no speed reduction. Okay. And the diameter of these two would be same, whatever. The number of teeth would be same, everything would be same, isn't it? So transmit the power of how much? 37.5 kilowatt. So the given value was just right here. So power to be transmitted is how much? It is 37.5 kilowatts. I have mentioned both are of equal size, pinion as well as the gear. So it is N1 is equals to N2, D1 is equals to D2, and Z1 is equals to Z2. The same I have mentioned. And even I have mentioned here D1 is equals to D2. That's why the value of I is equal to 1, because both are of same diameters. With the moderate shocks, so moderate shock word he has used. So I would just write moderate shocks. This helps us to calculate certain value, isn't it? At 1200 RPM, the speed is given as how much? 1200 RPM. 1200 RPM. Next. The two shafts are parallel and 0.45 meter apart. So what is that 0.45 meter apart? That is the distance between these two. So I can take it as A, which is the center distance, that is given by 0.45 meters apart. Each gear is made up of steel. So he has mentioned the word steel. So it's very clear that it is made up of steel. And even here is given the value of helix angle, which is 30 degrees. So this is the data given. So from this, if the center distance is known, that is 0.45 meters, can I calculate the diameter of the one, since both the diameters are equal? Center distance can be calculated by D1 plus D2 divided by 2, that is equal to 0.45. Now, since D1 equal to D2 equal to same value, that is, I could take it as D, so it would be 2 times of D. So 2 would get cancelled. D would be again 0.45 meters. Clear? Any doubts until now?
No, sir.
We shall move on with the solution then. Now, I need the answers at a very faster rate for this because nothing is different from now. From now, everything is same. Whatever the problem you have solved in the previous class, same repetition. So if you solve 3 to 4 problems on spur and helical gears, you will be bored with it. I'm literally saying you will be definitely bored with it because every problem is of the same pattern. But the thing is, there are small concepts which I have highlighted in the red color. I have written in the notes clearly also. Those you have to write it in your notes and be very careful at those particular points. That's it. Okay, let us move on with the solution for this. I want you to be at a very good pace now, everyone. Okay, so solve it. I want everyone to solve this. Again, since both the materials are same, so both the materials are same, both the gears are same, pinion is equal to the gear here, but has he given us anything hint regarding the material? He has just said as it is a steel, isn't it? So we need to pick which type of steel we require. So always I told you, if nothing is specified in the problem in case of a spur and helical gear, I'm repeating it, in case of a spur and helical gear, for worm it is different thing. Okay, for spur and helical gear, you always assume C45 untreated steel, which is having sigma. From where all this data is obtained is table number 12.7 234. Just go to that table number 12.7. 12.7 12.7 234. Here it is. So C45 untreated. So this is the material. Always you choose for. As a lecturer, I should not say this, but for your easiness, what you do, you just zoom this. Okay, take a pencil and just mark a star here, so that you will come to know this is the material you have to take whenever the material is not being specified in the problem. Okay, there and there you can mark a little bit markings on your data handbook. No one will come and easily don't write the complete story. Okay, someone of I observed that data handbooks, I'll be keep checking because I am very much keen how students will mark on the data handbook. Okay, so I was checking the things. One of the student, what he has done, he have just written every definition in the data handbook there and here. Okay, it was wonderful to look at, and he was anyhow reported to the examination section. Okay, so don't do such type. You can just mark like this, so it will come to know that if nothing is given, you can select that particular material. From that, you'll get the value of sigma D1 and D2, which is 233.4 from the table itself, and BHN value as 1 and 2, which is 200. Next, identifying the weaker part. It is same, so pinion is made weaker here. Design is based on the pinion. So logically speaking, pinion is a smaller thing and a gear is a bigger thing. Okay. So since in this particular problem, in a special case, you have the size of the pinion is equal to the size of the gear. In such situation, if you take pinion also, if you take gear also, nothing gonna change. Okay. So since the number of teeth is not given, what you have to do is you have to assume Z1 to be 20. Even the Z2 value would be also 20 because I value is equal to 1 there. There is no speed reduction, therefore 20 teeth and 20 teeth both on the pinion and gear. Since it is a helical gear, I always told you whenever you hear the word teeth, automatically you yourself have to write the sentence. You have to change it to virtual number of teeth whenever there is a problem on helical gear. So pick the formula for the virtual number of teeth from 12.22a to 11. Calculate your virtual number of teeth 20, and what is the value of beta given? Beta is 30. So just write 30 and give me the virtual number of teeth. So this would be helpful wherever you will pick that particular value. We are calculating before itself. Okay. What is the value? So in this particular class, did I make you to play any kind of games? 26.67. Which one is the value? 26 or 30? Okay, most of them are saying 30.79. So I would take that 30.79. So yes, have I, all of you just start module calculations? Same thing, nothing has changed. Take that particular equation 12.24, which is for the module calculations of a helical gear. Go with it. Okay. So have I made you to play certain games in this, in the online mode? I'm asking you, since the online teaching has been started for DME 2, because I have 3 sections. I'm not in a.
Yes, sir.
Isn't it? Okay. So I think it is not done for ATD. D1 value is how much? D1 value
28.27.
Okay, directly have given 28.27. So it is way greater than 20 meters per second. So pick appropriate formula from the data handbook for the value of CD, which is greater than 20 meters per second. So I would just write here 28.27. Now let me tell you my mistake which I have done in my engineering time. Same gear problem was there. Okay. So here I need to substitute the value of the V, isn't it? Same sentence I have written. V is greater than 20 meters per second. Same sentence I have written. What I have done is I have substituted here 20. Got it? So such kind of things will happen in a hurry. Don't make that. Okay, 28.27. With the value of CV 0.45 it is 1200. 0.51 is the value. Now, tangential load calculations. So since he has given the moderate shocks, so he has nothing specified that whether this gear is continuously used or it is used for 8 hours or it is used for 4 hours. Nothing he has specified. So just write the sentence, assume 8 to 10 hours of service. This is the standard what we follow for moderate shocks and assumption of 8 to 10 hours of service. Give me the service factor. That is 1.5 taken from table number 12.8 to 35. So power is how much? Power is 37.5 kilowatts. So it is 37.5 kilowatts divided by V. V value is again 28.27. Now give me the tangential load in newtons. In the tangential load 1989. 1989. So 1989.74. This is the value from the textbook. Now, form factor. Next is form factor. While taking up the value of Y1, please be careful. It is not Z, it is ZE1 there. So what is ZE1? You have just calculated. It is 30.79. Same thing you substitute there. 30.79. Now give me the value of form factor. Navneet, Nandan, Nitesh, Are you there? Nandan, Navneet, and Nitesh.
Yes, sir.
Participate, no? You're participating very less nowadays. Nandan, Navneet, and Nitesh. Participate. 0.4528. 0.4528. That's great. Next. So since the value of the K or CW is not given, so again, standard values we have been following since the last many problems. Take the value of K to be 15 for helical gear and 10 for spur gear. CW is 1.15, so you can refer table number 12.21, 241. Standard lubrication thing, we have taken it as 1.15. Substituting all the values there. I'm not substituted, okay, I have to write. So all the values there, just substitute and calculate the value of module. So it is 1989.74 cross 1.15 divided by 233.4 cross 0.5107 cross 15 cross 0.4535. Module. Okay, 1.68. Standardize this particular thing using the table. Standardized values. Standardize the above value using table number 12.22. Sorry, 2, page number 229. 229. So if I start to look at it, no, the screen would get disturbed. Others will be just copying the things. No? So give me the value. Okay, 2 mm. First preference. Huh?
Yes, sir.
Okay. Okay. Why Gauss is insisting 1.75 Gauss? Muhammad Gauss. Okay, near. So what shall we do? We shall go with 1.75 or 2? 2. Yes. So as soon as you calculate n value, now next you calculate the number of teeth, because remember, if you miss these steps, around 3 to 4 marks will be deducted out of 20, because he has not given us the number of teeth. You are need to suppose that. Initially, we have assumed it. Initially, we have just assumed it. Now we are supposed to calculate it. Use equation number 12.9D in page number 211, which says Z1 is equals to D1 cos beta divided by Mn. Since now Mn you have just calculated. So it is 450 into cos 30 divided by 2. So give me the number of teeth. Okay, 194.8 in the sense, can I round it off to 195? Is that okay? 195. Now, since I is 1, again, this is also 195, which is on the gap. Again, it is 195 there. So now calculate again the virtual number of teeth. It is 195 here. Cos cube of beta. Beta value is again 30. Virtual number of teeth now. ZE1. ZE1. Okay, so 300.22, I will take it as 300. 300, good round number, so I'll take it as 300. Since I is 1, ZE2 is also 300 there. ZE2 is also 300. Now immediately calculate your face width, which is B divided by Mn. So you need B there. It is 15 cross Mn. Mn is 2. Normal module is 2 there. So your face width is 30 mm. Right? So once you calculate this thing, face width, what you have to do, immediately have to check for B. So I'll just call this app now. Now, both the things I am doing it simultaneously. Checking for B is my first job. Second job is checking for the design stress 1. Both the things I am doing it simultaneously. First, B minimum you have to calculate, and you have to show that whatever the B minimum value is there and whatever the B you have calculated, that is greater than the B minimum which was supposed to be. Okay. Are you getting disturbed with that sound? Shall I pause for some time or shall I continue? Okay then. Okay. 14.45. Mn is 2 and beta is 30. So what was the B that you have calculated is 30. So B minimum was supposed to be 14.45. So it is way greater than that, whatever the calculated value is that. So it is totally safe. Now check for sigma D1 now. Ft is equals to sigma D. Take this particular equation in 12.24, page number 214. Now you calculate Y, because don't use the previous Y, because there so don't use the previous Y, since there you have used the assumed the virtual number of teeth. Now previously you have just calculated the virtual number of teeth, no? With the proper calculations, you can use that particular thing here, which is 195, I guess. Okay, ZD1 195. Allah tane. Virtual number of teeth 300. Correct? Am I right? So what is the value of ZD1? 300 or 195?
300, sir.
Take it as 300 there. Calculate the value of Y.
0.539.
0.539. Now, substitute all the values in the above equation 12.24, which I have done here. Calculate the value of sigma D. Check whether it is less than 233.4 or whether it is greater than 233.4. If it is greater than 233.4, again a huge burden for us. You have to go there and increase the module to 2.5 or 3, referring the table. Again, you have to repeat the same procedure. $138. Thank God it is 138.73. So it is very much lesser than. Just write a sentence and leave. Since the calculated value is less than the permissible value, assumed values are okay. Okay. So once this we have done, what is our next step? Anyone? Module calculation is done. Next, what is our next step? The design. What we are supposed to do next? Anyone? Yashwant? Shashank K? Shashank yes K? Dynamic load. Go over the dynamic load calculations. Okay. So since face width was also asked, just write face width is equal to 30 mm. So already you have written it. No issue if you write it once again. So just mention B there if you want to mention neatly. So just mention subscript B and 30 mm. Next, go with the dynamic load calculations there. Use this particular formula from the equation number 12.26a214. Just the equation is big. Only the important factor here is C. So how do you calculate C is, again, I have calculated C. You can just watch it, see it here. So again, you have to refer two tables. From one table, you will be getting C. For getting that particular value of C, you require the value of E. For getting E, you have another table from which, from the velocity, you will get the value of E. Since V is greater than 20 meters per second, that is the highest value in that particular table. So we'll take this particular error value, which is E is equals to 0.0127. Now you take that particular error value and come back to the previous table, which is 12.12, which is in the previous page 236. Over there, you look for alpha is equals to 20 stub teeth and steel-steel combination. So you will choose the nearest value where error at 0.01 is given as 118.7 Newton per mm. Now, for error of 127, you require a value. Okay. For that, you can cross multiply the things. It is 0.01 cross C, and it is 118.7 cross 0.0127. So once you do that, you can send the 0.01 to the either side. It comes and falls in the denominator. So once you calculate the value, your value would be 150.75 Newton mm. So it is Newton per mm. I will just write it here, Newton per mm. So since the value of C is known, K3 is known, and all other stuffs are known, substitute the whole thing here. Substitute the whole thing and give me the value of the dynamic load. Sri Raksha. Sri Raksha. Are you there? Sri Raksha. Okay.
Sir.
So ನಿನ್ನ ನೋಟ್ಸ್ ನನಗೆ ತೋರಿಸು, ಏನೇನ್ ಮಾಡಿದ್ಯಾ ನೋಡುವ. Sri Raksha.
Sir.
Yes. ಎಷ್ಟೊತ್ತು ಬೇಕು? Sri Raksha. Time is up. I cannot wait more. Where is this fellow? Very good. Good. Next page. ಬೇರೆ ಎಲ್ಲ ಯಾರು ಬರೀತಾರೆ?
ಅಷ್ಟೇ ಬರ್ತದೆ.
ಇದರ ಆನ್ ಮಾಡು, ಕ್ಯಾಮೆರಾ ಆನ್ ಮಾಡಿ ಹೇಳ್ತೇನೆ ನಾನು. ಕ್ಯಾಮೆರಾ ಆನ್ ಮಾಡಿ.
ಅದೇ ಸರ್, ಇಲ್ಲೇ ಸ್ಟಾಪ್ ಆಗುತ್ತೆ ಹೆಲಿಕಲ್ ಗೇರ್.
ಒಂದು ನಿಮಿಷ ತಾಳು.
ಮತ್ತೆ
A pair
ಮತ್ತೆ
of
ಬರಲಿಲ್ಲ ಸರ್ ಇಷ್ಟು.
gear. A pair of helical gear ಎಂಬುದು ಯಾವ ಪ್ರಾಬ್ಲಮ್ ಅದು?
ಫಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ ಸರ್, ಫಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್.
ಹೌದಾ? ಮತ್ತೆ ಬರೀಲೇ ಇಲ್ಲ ನೀನು. ಹೀಗ್ ಮಾಡಿದ್ರೆ ಹೇಗೆ?
ಇಲ್ಲ ಇಲ್ಲ ಸರ್, ಈಗ ಮಾಡ್ತಿಲ್ಲ, ಕೇಳಿದ್ ಮಾತ್ರ, ಸ್ಕ್ರೀನ್ ಶಾಟ್ ತೆಗಿತೇನೆ.
ನನಗೆ ಗೊತ್ತಿಲ್ಲ, ನೀನು ಎಲ್ಲ ನೋಟ್ಸ್ ಅಪ್ಡೇಟ್ ಮಾಡಿ ನನಗೆ ಕಳಿಸುವವರೆಗೂ face the consequences. I'm sorry.
ಓಕೆ ಸರ್. ಓಕೆ ಸರ್.
ಸರಿಯಪ್ಪ. Sriraksha. See, the thing is, you have to solve, guys. If you do not solve it, you will never ever come to know. ನಾನೇನು ಜಾಸ್ತಿ ಮಾಡೋದಿಲ್ಲ, ಮಿನಿಮಮ್ 4 to 5 ಮಾಡಿಸ್ತೀನಿ, ವೇರ್ ಇಟ್ ಕವರ್ಸ್ ಎವ್ರಿಥಿಂಗ್, ಎವ್ರಿ ಪಾರ್ಟಿನ ಟಚ್ ಮಾಡಿರ್ಬೇಕಂತ ಒಂದು ಪ್ರಾಬ್ಲಮ್ಸ್ನ ಸೆಲೆಕ್ಟ್ ಮಾಡಿ ಸಾಲ್ವ್ ಮಾಡಿಸ್ತಾ ಇರ್ತೇನೆ. If you don't solve it in the class, it's very difficult. I did not expect this from Sriraksha. How much is the value? 1998.71. So 1998.71 newtons. So as soon as you calculate your dynamic load, next to go for the endurance load, which is represented as FS in your data handbook, or it is given as FEN. For that, you can go with equation number 12.26, B, page number 214. Okay, go with that particular equation there. Okay, so for obtaining the value of sigma En, what you can do is you can go with table number 12.15 to 38. 238. In this particular, this thing, you can get the value of PHN from there, pick the value of sigma En. Okay. So here you have the value of sigma En. Pick that particular value, substitute everything, and give me the value of FS or FEN. Endurance load. We are checking for the endurance. Fatigue you've heard of, right? So checking for that particular load, whether your designed gear can withstand fatigue or not. So that is what we are checking.
ಹಲೋ ಸರ್, ಶ್ರೀನಿಧಿ ಕರೆದ್ರ ಸರ್?
ಯಾರನ್ನ?
ಶ್ರೀನಿಧಿ
ಕರೀಲಿಲ್ಲ.
ಆಯ್ತು ಸರ್.
ಇನ್ನ ನೀನು ನನಗೆ ನೋಟ್ ಸಬ್ಮಿಟ್ ಮಾಡ್ಲಿಲ್ಲ, ಹಾಗಾಗಿ ನೀನು ರೆಡ್ ಅಲ್ಲೇ ಉಂಟು. ನೀನ್ ಯಾವಾಗ ಸಬ್ಮಿಟ್ ಮಾಡ್ತೀಯ ನೋಡು. ಅದು ಇಂಟರ್ನಲ್ ವರೆಗೂ ಹಾಗೆ ಇತ್ತು ಅಂದ್ರೆ ಡೆಫಿನೆಟ್ಲಿ ನಾನು ಈ ಸರಿ ಅಂತೂ ಮಾರ್ಕ್ಸ್ ಕೊಡೋಲ್ಲ. 11.15. What can I write the sentence? So even I would write this particular thing in kilonewtons. Okay. 1.19 kilonewtons. What is the statement? 11.15. Just 1.9 kilonewtons. Correct. 1.9 kilonewtons. What is the statement? So your endurance strength or endurance load is greater than the dynamic load. So what will be a statement? Just write the statement. Since Fs is greater than Ft, the material is safe against static load. Even in the bracket, you can write it as the fatigue load. Okay, both are the same thing when it comes for the gap. So next, check for wear. Okay, go with the wear calculation. So wear load is given by the equation 12.26C, page number 214. Okay. D1 is 450 mm, and Q will be equal to 1 because D2 is equals to D1. No, if you substitute and calculate also, it would be 1 there. And for alpha, pick the value of K. So you by this time would be in a position to understand the importance of K as well as the value of C in calculating. So the importance of value of C in calculating the dynamic load and the importance of calculating of value of K in the wear load. You have understood, right, how important these two values are. These two values play a very important role in the calculations of wear load and dynamic load respectively. Okay. So what was the table number? Table number. K calculation table number is
239.
12.39. Huh?
12.16.
239.
Okay. To 12.16 page number on Kodi.
239.
Page number 239. Thank you. Now K value from that particular table. For BHN is 200 steel combo. Alpha is equals to 20. .539. Okay. I'll take that. So it is 0.539. So 0.539, substitute there and give me the value of FW and check for whether it is safe or not. Motor to be there.
9702.
How much?
9702.
9702. Oh, 9.7 kilonewton. Na. Then textbook prakara material is safe anta barabeku. So what was our value there? FD value. So how many of you got this FD value? Is the FD value whatever you have given is correct? Everyone got the same value? Okay. Okay. So according to the textbook, let me check. FD. According to textbook, it is 613,051 Newton. 0.5 ando. So it is 6.1 kilonewton. Something fishy. So everyone are getting the same value then? 1.9 kilonewton. Just raise your hands. No need to type this. Already you have done it. Okay.
Sir, that FD equation is wrong substituting.
Where?
Plus, sir, FD plus 20 plus 7 into 2 into 1 to 6, 7. There is no plus, sir. Into.
Achha, there is no plus over there. Let me check. Correct. ಇಲ್ಲಿ plus ಇಲ್ಲ. ಇದು ಯಾಕೆ ನಾನು plus ಬರಬೇಕು ಹಾಗಾದ್ರೆ? It is no plus. Now you check. Correct ಈಗ?
Yes sir, 6.7 ಬರ್ತದೆ.
6.7 ಬರ್ತದಲ್ಲ. So I would just change this to 6.7. 6.7 kilonewton. Okay. ಆದ್ರೂ ನಮಗೆ ಬೇರ್ ಲೋಡ್ ಎಷ್ಟು ಬಂದಿದೆ? 9.7 kilonewton. ಈಗ ಮಟೀರಿಯಲ್ ಸೇಫಾ? ಬೇರೆ ಲೋಡ್ ಜಾಸ್ತಿ ಬಂತಲ್ಲ, ಮೊದಲೇ ಜಾಸ್ತಿ ಬಂದಿತ್ತು. ಆದ್ರೂ I was not satisfied with the value of dynamic load. That is why I have cross-checked it. Anyhow, now it is clear. You change ಮಾಡಿದಿರಲ್ಲ ನಿಮ್ಮ ನೋಟ್ಸ್ ಅಲ್ಲಿ ಎಲ್ಲರೂ 6.7 kilonewton ಗೆ? Just raise your hands. Okay. Fine. Now, yes. So wear load ಬಂದ್ಬಿಟ್ಟು 9.7 kilonewton, dynamic load ಬಂದ್ಬಿಟ್ಟು 6.7 kilonewton. So it is definitely greater than dynamic load. So material is safe. And allige namma problem mugit. Okay, next particular problem, which is this. Okay, just all of you take the screenshot of this particular problem. So this is an example of someone asked the doubt regarding this. In certain amount of problems, their diameter will not be given. If diameter is not given, there will be very much issues would be generating while calculating the module. Okay. For that, how to do it, we will discuss in the next class. And you have just take a screenshot of this particular thing and write the questions and write the given data. Identify the weaker part. We will do it in the next class. Okay, simple. If you want to try, you can even take the screenshot of this. So in module calculations, the first formula you will be generally using this particular formula. Okay, you will be using this formula. Till now we have used this formula. Now if the diameter is unknown, you have to use the second one, which is just to decide it. Rest all, everything is remains same. Okay, so just try that particular thing. Now as of now, just you can take the screenshot of this. We'll meet up in the next class. All of you just mark your attendance in the Google Sheet and you can leave the class. Okay. Take care then.